When writing the equation of a line, there are two formats of an equation that are convenient in that we can just look at the equation and take all the information that we need to be able to sketch the graph. And the first of those is slope-intercept form. When an equation is written in this y equals mx plus b format, we can see the two pieces of information that we need to graph. We see what the slope is, that's the number that's multiplying the x, and then we see what the y-intercept is, the place where the graph crosses through the y-axis. As long as we know those two things, where the line is in the form of the y-intercept and how it travels through that location in the form of the slope, we can graph the line. And so a lot of times we're asked to kind of work backwards from information. So instead of sketching the graph, we can be given information about the graph and have to come up with a line, which is what we're going to do here. So we want to write the equation of a line that has a slope of -3/4 and passes through the point -8,1. So in this case, if we want to write it in slope-intercept form, there are two things we need. The slope, which is given to us, so we can get as far as y equals -3/4 x, and then we don't know the y-intercept, so I'm going to leave that as plus b. So far we're halfway there. To get that other half of the information we need, the y-intercept, I'm going to use the point that's given to us, this -8,1. And so since I know my line travels through it, I know that that point is going to work in my equation. So I'm going to plug those numbers in for x and y and then solve for b. I just have to be careful about the sequence. So in place of y, I'm going to plug in the 1, since that's the y coordinate. I'm going to have 1 equals -3/4 times -8 plus b. So if we scroll down a little bit, give ourselves a little more room, we've got 1 equals, so negative times negative is a positive, 3/4 of 8 is 6, so we have positive 6 plus b. So if we subtract 6 from both sides, we get b equals -5. And so now, after having been given the slope, we have found the y-intercept, so we can write the equation. So that's going to be y equals -3/4 x minus 5. In the case of the second example, we've got neither of the two key pieces of information given to us. We're neither given the slope like we were in the previous one, nor are we given the y-intercept. We're just given 2 points through which the line travels. So for us, on this one, we're first going to have to figure out what that slope is using the slope formula. So recall that that's m equals y2 minus y1 over x2 minus x1. So I just need to designate one of these as 0.2 and one of these as 0.1. We'll go ahead and just go in left to right order here, but it ultimately doesn't matter. So we've got m equals, so y2, the y coordinate of the second point, is 3, minus the y coordinate of the first point is -3. And then for the x's, x coordinate of the second point is 2, minus the x coordinate of the first point is -6. So we're ending up with 3 minus -3, so that's going to be 6 over 2 minus -6 is going to be 8. So this time we're ending up with a slope of positive 3/4. So there's our slope, so we can go ahead and slot that into our equation. Y equals 3/4 x, but we still don't know what the y-intercept is, so plus b. Now we're going to approach it the same way that we did on the previous question. But now I have a choice. I can use either of these 2 points and plug it in to figure out what my y-intercept is. So I'm going to go with the positive option here just because it's less things for me to lose track of as I plug in. So in place of y, I'm going to put 3 equals 3/4 times, in place of x, I'm going to put 2 plus b. So we get 3 equals, if we do a little cross-canceling reducing, we've got 3/2 plus b, or 1.5. So if I subtract that from both sides, 3 minus 1.5 is 1.5. But I'll go ahead and leave it as an improper fraction, just a little bit more convenient to work with in many circumstances, so we should be comfortable with that. So in the end, we get y equals 3/4 x plus 3/2. So don't be put off by a fractional value for the y-intercept. Sometimes that works out. A little tricky to graph, but we're fine with this as a solution here. So a second convenient format for an equation to be written in is called point-slope form. And in point-slope form, we're in a similar circumstance where we're given the slope, so that number is what's multiplying the x part of the equation. But now for the where the line is, instead of being given the y-intercept directly from the equation, we're able to deduce a random point that's anywhere along the length of that line. So it's not necessarily the place where the graph crosses through the y-axis, it could be anywhere. And so the coordinates of that point are x1, y1, as we see here. And the tricky thing is the positive and negative signs that we see in the equation, because it's x minus the x coordinate of the point and y minus the y coordinate of the point, the positive negative sign that we see in the equation is the opposite of that of the actual point. So in the example that we have here, we're going to write the equation in point slope form this time. So again, two pieces of information we need: a point, of which we have two this time, so we can choose either one of those eventually. And then we also need the slope, which is not given to us. So we're going to use that same slope formula, m equals y2 minus y1 over x2 minus x1. And so I'm just going to designate these as, this time I'm going to use this one as 0.2 and this one as 0.1, just so that the one with the positive values comes first. So the y coordinate of 0.2 is going to be 3 minus the y coordinate of 0.1 is 4. The x coordinate of 0.2 is 4 minus the x coordinate of 0.1 is negative 4. So we end up with 3 minus 4, negative 1 on the top, and then 4 minus negative 4 is 8. So we have a slope of negative 1/8. And so the nice thing about this is essentially our work is done, because now in my y minus y1 equals m, so I've got negative 1/8 times x minus x1. I just need to pick one of these 2 points to plug in for x1, y1, and I don't have to do any solving like we do on the y-intercept, slope-intercept equations. So I'm going to go ahead and use this point right here. Again, it's the one with the positive values, so less likely chance of a mistake, but I could have used the other and it would be just fine. So we get y minus 3, make sure it's the y coordinate there, equals negative 1/8 times x minus 4. And again, we used the one we designated as 0.2, even though in the equation it shows up as x1, y1. Don't be distracted by that. It just needs to be a point that the line travels through that we use for that in our equation.